Hello. Can you hear me, Shanavas? Give me a second. Hello, not yet. For reason which I don't really know, I cannot hear you, my friend. Would you please write a chat? My volume. Yes. Shanavas, can you hear me? You can. So the problem is from your side.
My friend, can you hear me now?
Yes, now I can. How are you, my friend?
I'm doing good.
Happy to see you. You look very nice, very well.
Thank you so much, my friend.
My friend, would you like to go with us to Hollywood?
Yeah, but I am getting echo.
Tomorrow, the Prabhata Data is going to give a talk. So I'm going
Yeah.
to send you the link. He's going to talk about metaverse.
My friend, I'm getting echo.
You are getting what?
Okay, please wait a minute. Give me a moment. Yeah. Could you hear me now clearly?
Yes, very well. Yes.
Yes, my friend. Now everything is fine, my friend.
Yeah. As I was saying, I'm going to send you the link for tomorrow.
Yes, please, please.
Data is going to deliver a webinar.
Yeah.
And well, you know him. He's really clever, the man.
Yeah, my friend. I know him very well. Yes.
Yes, you know him. Well, and how are you doing, my friend?
Yeah, my friend. Everything is fine so far. No problem. No big problems. It's going fine.
And how do
And
you
it is.
feel on your own?
Yeah, my friend. I'm quite engaged with the activities in universities, and so it's good. Next week, I am going to India, my friend, for a week.
For a week. That's very good. And you go
Yeah, my friend.
visit your parents, your child, and everybody.
Yes, my friend.
That's very good. I'm happy to hear so. How long are you going to stay there? Only going 1 week?
Yes, my friend. Only 1 week.
So when are you leaving the place where you are at the moment?
I will be there on 17th.
On the 17th. So
Yeah,
you will
my
be
friend.
there until the 24th, 25th, or
26.
26th, because the 25 is what we call the Christmas, right?
Yeah, yeah, my friend.
Well, my dear friend, it is a real pleasure to know that you are doing well. And how your
Yeah, my friend.
wife, how is she doing?
Yeah, my friend. She's doing good. Everything is fine for her. No problem.
And your mom?
Yeah, my friend. She's also good, my friend.
Yeah. Well, and I'm planning to get in touch with Sharon and see
Yeah.
how the situation is going now with 3 kids, which is
Yeah, my friend.
it's like an army. It's, quite a lot of
Yeah.
well, but you are fine. Well,
Yeah, my
you tell me when I can introduce you, and you can start, my dear friend. You say when?
Yes, my friend.
Yeah,
Yeah, I'm ready now.
yeah. So, well, good afternoon, good night. I don't know which part of the world the people are listening to or are going to listen to this webinar. Now, this talk is going to be delivered by Dr. Shanavas, Shajahan. And this is it's called material for sustainability. Well, I do thank Chanamal for your kindness, and you are very polite to give us the kind of seminar. Because you see many people and need this and new knowledge and that kind of things. So what we are trying to do at the moment is trying to make our effort a bit more solid and more regular in time. So people will be able to get more and more, which is something we all need. Okay, my dear friend, as usual, it is a real pleasure to welcome you, a member of my family. And please start with your talk.
Thank you so much, my friend. And it is very happy to hear you saying me as a Dr. Shanavas. I grew up in your home, and I'm feeling like from kid to what I am now. Thank you so much for everything you did for me for the last few years. Thank you so much for that, my friend. And now I'm going to share my screen.
Yes, you can do that. I'm going to mute, not to make any noise for you.
Can you see my screen? Yeah, my can you see the screen, my friend?
Very well indeed. Please just go ahead, my dear friend.
Yeah,
I'm going to mute, right?
yeah, my friend.
To avoid
Very
the noise from here. Okay, my friend.
yeah,
Welcome.
yeah, my friend. Thank you so much. Thank you so much for your nice introduction. And yeah, I need some adjustments. Yeah, yeah, yeah. Today I'm going to discuss about the more like a sustainability things to for environmental hazards and its effects and solutions. How sustainably we can came across these environmental hazards, and I will discuss about the effects of these hazards which we are already facing and its solutions. I am Shanavas from Department of Chemistry, Khalifa University. Yeah. Today, the outline of the talk today will be the major environmental issues: land pollution, air pollution, water pollution, sustainability and its necessity, photocatalyst, and conclusion. Major environmental issues. Today, world is facing a huge backlash due to the rapid development of industry. The rapid development of industry is must for a urbanization of a human mankind and development of a mankind. Still, it has some setbacks which actually dragging us towards the destroying our own planet. Something like most probably these the expansion of these industries are causing air pollution, water pollution, and land pollution, which is most common, and it is due to the very hazardous chemicals and waste products discharged from these industries. And these industries actually, this pollution is actually causing a land degradation where it is actually affecting the fertility of the land. That is called a land degradation. And so it is drastically affecting the farming lands, which will sustain in a long sustained manner. It will affect the production of food for a human being. And loss of biodiversity, where this pollution is actually cutting the cycle, biodiversity cycle. And ozone depletion, which is a big problem. And climate change, which we are experiencing now. Last year we saw a heat wave in Europe, and next year we are expecting heat wave in India as per survey. And all of these things are due to this rapid development of industries as well as other factories. Yeah, we know that it is needed. We need industries, we need factories to grow, but still it has some advantages. Now the mankind is focusing how to overcome these disadvantages, and so we can make the things more sustainably. Environmental pollutions more basically uh, structured into a land pollution, water pollution, and air pollution. Land pollution, most of the land pollutions are due to the use of pesticides, which is highly synthetic pesticides, and deforestation, mining to produce ores, and industrializations, which I already said that to you, and landfills, chemicals, and nuclear waste. Actually, these are the things which actually we need to run our life, but still the over exploration and improper dumping of byproducts we are getting out from these things is actually destroying our lands. The global plastic pollution, the here in this image we can see that the globally plastic pollution contribution of human beings, and where in India 0.01 kilograms of plastics were discharged by each Indian per day. It means India is a very big country with 1.5 billion people. You can imagine how much there will be tons and tons of plastics are actually getting dumped on the landfills. I'm talking only about India. Just imagine what is happening there in the US, in Russia, in China, Latin America, everywhere. The pollution is huge, and air pollutions. The biggest causes of air pollution is the industrializations as well as using of fossil fuels. Fossil fuels are used to produce energy for automobiles, power plants, industrial plants, and etc. The burning of these fossil fuel releases the toxic gases, which actually is the prime reason for the global warming. And in addition to the fossil fuels, biomass burning like a forest fire, burning of fuel woods, and the agriculture remaining, burning the agriculture remaining, which is happening everywhere around the world, and especially in India, I can really experience that how much of waste agriculture remaining they are burning each year. That's huge. And industrial discharge. This is what I am talking about before. The gaseous pollutants include carbon monoxide, hydrocarbons like methane, ethane, and oxides of sulfur, oxides of nitrogen. These pollutants are highly toxic and it is affecting our quality of air very rapidly. Global air pollution. This is the survey where you can see the average pollution rate all over the world. You can see here the pollution contributed by these countries, the fast growing countries, is very, very high when compared to the grown countries, when compared to the first world countries, because these countries are trying to emerge more many huge amount of industries to develop their country and their economy. Due to those things, the discharge of the pollutants from those newly developing industries also very high, that is affecting the air very, very badly. And we can see that the developing countries were emitting the more air pollution when compared to developed countries. And it is the annual carbon dioxide emitting countries where you can see that China and Russia is leading the chart. It is due to the very huge usage of cars there in those countries. In addition to that, very large amount of factories and industries there, and followed by the India and Russia. And rest of the world is emitting about 21% of carbon dioxide. Still, this ratio we can clearly see that these developed countries and developing countries are the huge emitter of the CO2, which is a greenhouse gas, which actually plays a major role on the depletion of ozone. This is the top annual CO2 emitting countries by rank, and where you can see that India lies in third, and first China lies first, and followed by United States, India, Russia, Japan, Germany, South Korea, Islamic Republic of Iran, Indonesia, and Canada. Wow, wow. What are the effects of this air pollution? Basically, air pollution has several long time effects. Still, the rapid spontaneous effect, these are the spontaneous effect like headache, fatigue, respiratory illness, cardiovascular illness, and cancer risk, yeah, and skin irritation. Water pollutions. Water pollution due to the rapid development of industrial yeah, organic industries and textile industries, pharmaceutical industry and textile industry, huge byproducts were discharged in the water resources. Those discharged byproducts is a huge source of water pollution. There you can see that in case of India, almost 30% of these pollutants were discharged to the water resources without proper purification process. And these organic pollutants were discharged from the effluents from home and hospitals, manufacturing factories, pharmaceutical companies, and inappropriate disposal of medicine, as well as aquaculture treatment. Now here we can see that the countries polluting the oceans the most, surprisingly, India is not there, because India is mostly based on, India has many rivers, and so most of those pollutants are discharged on the rivers. But you can see that China is leading the chart again in the polluting in water, polluting in oceans also, where you can see that China, it has a huge proportion, almost a one-third of any other countries, for all other countries in the world, and followed by the Indonesia, Philippines, Vietnam. These Vietnam and Philippines, Indonesia, these countries are surprised in this chart, but still it is due to the rapid industrialization. Due to the change in economy sanctions, as well as economy models, industries were get attracted by these countries like Philippines, Vietnam, and so they are building more amount of industries and they are discharging more pollutant. Direct effect of water pollution. There are several direct effects. Still, the major effects are cholera, typhoid, diarrhea, hepatitis A are the huge direct effect of the water pollution. And you can see that almost something like a 70 to 80% of kids are getting affected due to the impure water, drinking of impure water. There are some water purification techniques. There are several traditional techniques are there to purify the water resources, like absorption on carbon, ultrafiltration, liquid separation, coagulation by chemicals, and oxidation. Still, these techniques are not economically favorable. In addition to that, the secondary pollutants produced in these techniques is much further deadly than a primary. And so we need some alternative technique which can entirely remove the pollutants from the water resources.
My friend,
Addition to that,
excuse me, the main screen is freeze, and we cannot see the slides. Now we can.
can you see me this slide?
And now, yes, it says water purification techniques.
Yes, my friend. Yes.
Sorry.
Did you able to see those previous sites or not?
Not at all, actually.
Okay, now it is fine.
Now it's lovely.
Yeah, my friend. Yeah. Yeah, the increase in the cost of purification techniques is also a huge problem, and so we are trying to get some efficient technique to remove the pollutants from water resource, and those techniques should be highly sustainable. Let's see what is sustainability. Sustainability means meeting our own needs without compromising the ability of future generations to meet their own needs. It means whatever we do now, it should not affect our future generations. And safe and secure food supply, the needs like a safe and secure food supply systems, clean water, safe and sturdy shelter, basic energy systems, sanitation, and high quality healthcare and education. Environmental sustainability, things in which we have to concentrate on the environmental sustainability is ecosystem management, electronic stewardship, energy, sustainable acquisition, sustainable buildings, vehicle and fuel use, waste minimization and pollution preparation, and water conservation. These are the straightforward things to make the future very sustainable. Photocatalyst. Photocatalyst. As I said before, we need some techniques to purify the water resources without production of any secondary pollutants, secondary dangerous pollution. In order to achieve that, there are several techniques. Still, the most advanced technique is advanced oxidation of those organic molecules by using yeah inorganic non-toxic material, especially something like a photocatalytic material. First, catalyst. Catalyst is nothing but which enhance the rate of reaction, and photocatalyst is nothing but which enhance the rate of reaction in presence of light. Where you can see here, when light falls on the photocatalytic material, the electrons from the valency band will get excited to the conduction. These excited electrons will undergo oxidation process to produce hydroxyl radicals, and the holes in the valency band will undergo reduction process to produce hydroxyl radicals. These hydroxyl radicals and superoxide radicals will undergo further degradation process to degrade organic molecules. Advantage of photocatalyst. Photocatalyst is relatively cheap and it is very sustainable because it is highly recyclability and it doesn't produce any further pollutants, and it is energy saving where it will use only a solar energy, and it's eco-friendly where it converts hazardous organic contaminations and bacteria into harmless products. General photocatalytic mechanism. As I said before, when light falls on the photocatalytic material, the electrons from the valence band will get excited to the conduction band. Those excited electrons will undergo reduction process to produce superoxide radicals. And while electrons excite from valence band, the hole will be greater on the valence band. These holes will undergo oxidation process to produce hydroxyl radicals. These superoxide radicals and hydroxyl radicals will react with the organic molecules to split down and cut it down into carbon dioxide and water. Semiconductor photocatalysis. There are different types of photocatalysis. Still, we are concentrating here on a semiconductor photocatalyst because when compared to other types of photocatalyst, semiconductor-based photocatalyst is most effective candidate for advanced oxidation process due to their easily adjustable optical band gap energy and very feasible technique for synthesis. There are some few example of photocatalytic materials are TiO2, Fe2O3, tungsten oxide, molybdenum sulfate, zinc oxide, tin oxide, zirconium oxide, cadmium sulfate. These are some very few highly explored photocatalytic materials. You can see that banded position of these photocatalytic material were easily adjustable. Still, we have some limitations on these photocatalytic materials where bandage position of this semiconductor photocatalyst should be at the particular position where it can undergo oxidation and reduction process to degrade the organic molecules. In addition to that, it should have some particular band gap energy, and so it can absorb the solar light as much as possible. And the photooxidant charge transfer separation and transportation efficiency should be very high, and so efficiency of degradation reaction can be improved. Strategies to construct better photocatalyst is to by increasing photoresponsive ability, by improving photo-induced charge carrier separation transportation efficiency, by forming oxygen vacancies in photocatalyst by doping and compositing with other material, by trapping of photo-induced charge carriers to reduce recombination, and by constructing a photocatalyst with appropriate bandage positions, as well as making the surface of photocatalyst highly reactive.
Excuse me, my friends, the screen is froze.
Screen is closed.
It froze. We cannot see the slide you are talking about.
Can you see this now? Strategies to construct better photocatalyst.
No, the only one I can see is one with the title water strategies to construct better photocatalytics. This is the one.
Yeah.
That is slide number 24.
Yeah.
But when you start talking, the slide do not move.
Yeah, I will go another technique to share the screen.
Yes. Thank you very much.
That will help. I think now you can see everything clearly.
Yes, yes. Now it's
Yeah,
yes,
yeah. Graphene.
yes,
Graphene is the king of materials where uh, I talked about the photocatalytic material. We discussed about the photocatalytic properties of the graphene, where graphene is the king of material, where carbon atoms were binded with the adjacent carbon atoms with sp2 hybridization. This graphene is a two-dimensional material, and so it will have a huge amount of surface to interact with the organic molecule. There are several advantages of graphene, like it has very good optical transparency with superior electron mobility, large surface area, excellent affinity, and very high thermal conductivity, as well as good optical transparency. Graphene is a hexagonal structural element of some carbon allotropes, including graphite, charcoal, carbon nanotubes, and fullerene, where graphite is the layer of carbon formed by the stacks of 41 of graphene sheets. 41 graphene sheets separated by 0.3 nanometer and held together by weak van der Waals force. Each atom forming 3 bonds with each of its nearest neighbors, known as the sigma bonds. The fourth valence electron is in 2pz state, oriented perpendicular to the sheet of graphite, forms a conducting sigma bond. The two-dimensional sp2 hybridized forms of carbon. It has two-dimensional sp2 hybridized forms of carbon. It has zero band gap energy. It is zero band gap semiconductor with two linearly dispersing bands that touch at the corners of the first Brazilian. And chemical properties. These are the chemical properties of graphene, where graphene is chemically the most reactive form of carbon, only form of carbon in which each single atom is exposure for chemical reaction from two sides. You can see that, my friend.
yes, very well.
Yeah, yeah. You can see that graphene is a two-dimensional structure. It means graphene can easily interact with the other things, other atmospheric things, in both the dimension, in top and bottom, where each and every carbon atoms in the graphene is exposed, and so the chemical reactions will be very highly efficient. The carbon atoms at the edge of graphene sheets have spherical chemical reactivity. The graphene burns at very low temperature at around 350 degrees Celsius. Graphene has the highest ratio of edgy carbons in comparison with similar materials such as carbon nanotubes, fullerene, multi-wall, and single-wall carbon nanotubes. Graphene is commonly modified with oxygen and nitrogen containing functions. Electronic properties. It is a zero overlap semi-metal where both holes and electrons are are charge carriers with a very high electrical conductivity. Electrons are able to flow through the graphene more easily than through even in copper. It means electrons in the graphene can easily pass through when compared to other metals. The electrons traveling through the graphene sheet as if they carry no mass as fast as just 1/100 that of the speed of light. Mechanical properties. To calculate the strength of graphene, scientists use a technique called atomic force microscopy. It is found that the graphene is harder than diamond and about 300 times harder than steel. The tensile strength of graphene exceeds 1 Pascal. It is stretchable up to 20% of this initial length. You can see the illustration of mechanical property of graphene where it can withstand the uh, pressure created by a huge helipant. Yeah, thermal properties, we know this much. The scope of this research. In this research, we prepared the RGO, reduced graphene oxide based nanocomposite, and we studied the structural, morphological, optical, and photocatalytic properties of prepared nanocomposite. And we examined the photocatalytic degradation ability of this nanocomposite, and we investigated about its mechanism. Synthesize technique, we synthesized RGO, Fe2O3, GC3, and 4 ternary nanocomposite, where initially we took Ferric oxide, ferric nitrate and copper nitrate as a ferric nitrate and copper nitrate as a precursor solution, and it is treated along with a melamine at 80 degrees Celsius to form a supermolecular frameworks, and then we did a calcination to produce a metal oxide on surface of the graphitic carbon, followed by the synthesis of ternary material, where we used to reduce graphene oxide as a third material with our binary nanocomposite. We used a hydrothermal technique to prepare the ternary material. We used these techniques to characterize our prepared material, where structural analysis, the structural properties of synthesized materials were analyzed by using XRD analysis, where the XRD analysis of ternary nanocomposite clearly shows the formation of ternary material, which is the combination of all the material we expected to be there. Functional group analysis. The functional group, the surface functional properties of synthesis, ternary, surface chemical properties of synthesis, ternary, binary and pristine materials were analyzed by using FTIR analysis. There, these FTIR results clearly portrays how the ternary material is binded together, where you can see that the presence of this bond 1640 and all these bonds is due to the aromatic carbon-carbon bonding and carbon-oxygen bonding, and it clearly shows the binding of carbon from graphitic carbon, either graphic carbon or an RGO is bounded with the Fe2O3, and so we are the formation of ternary material is confirmed. Morphological properties. The morphological properties of synthesized ternary nanocomposite clearly shows the formation of deposition of Fe2O3 on the surface of two-dimensional graphitic carbon as well as graphene sheets, and it confirms the formation of ternary material. And these TEM images, these high resolution TEM images clearly shows the highly embedment of this Fe2O3 on graphitic carbon sheets as well as RGO sheets. Chemical state analysis. The chemical states of elements present in the ternary nanocomposite were analyzed by using XPS analysis, where these peaks clearly shows the formation of Fe2O, further confirms the Fe2O3, where it is responsible for the bonding between Fe ion and oxygen, Fe and oxygen element, and these peaks are due to the binding between carbon and oxygen. UVDRS analysis. For a better photocatalytic material, it should have a very good light absorption property, and so we studied its light absorbing property by using a UVDRS analysis, where we can clearly see that 4FC3G, this ternary nanomaterial, exhibits very good absorption on a visible region with a very low band gap energy of about 1.82. Photocatalytic evolution. The photocatalytic properties of synthesis pristine binary and ternary nanomaterials were evaluated by using tetracycline molecules as a model pollutant, and you can clearly see that almost 100% of these pollutants are degraded within 40 minutes of degradation experiment. Reactive species generation experiments. These experiments were used to analyze the predominant radicals produced in the photocatalytic process, which tends to degrade the organic pollutant. And this is the proposed photocatalytic mechanism, where this mechanism clearly shows the shifting of electrons from one material to another material, and the excitation of electrons from valence band to conduction band of a material. You can see that the transfer of electrons is in Z scheme. Yeah, the conclusion of our research is we synthesized a ternary nanocomposite and we study this property. The prime findings of our material lies on its mechanism. We understood how the ternary material is actually working, how the electrons is transferring in the ternary material. This will help us to design a more nano composites in the future. Yeah, thank you. Yeah, my friend.
Actually, it was a very nice talk, actually. I had to congratulate you. Very, very nice
you.
indeed. What I would like, if you can you send me the presentation?
Yeah, yes, my friend, I will send that.
Because I'm taping this, so I'm going to send you the link if you want to see your presentation there in the city where you are is called Abu Dhabi.
What,
Abu
my friend?
Dhabi, where you are
Yeah.
at the moment, Abu Dhabi.
Abu Dhabi. Yeah.
Yeah, I'm trying to learn that because the only one I know actually Dubai, which this is not Dubai. Right. Well, it has been a pleasure, and I
Yeah.
hope that you will make more progress.
Thank you
And
so much.
more important than that, my friend, that you are going to be a very happy guy along with your wife and your family. And don't forget us. We are always think of you. And we, well, our fond regard, best wishes, and don't forget that you are our family. So do take care, stay safe, and be happy, which is the most important thing in this life. Okay, my
Thank you
friend.
so much.
Thank you very much indeed. Bye bye.
Bye, my friend. Thank you so much, my friend.
Take
Bye-bye.
care.